with the understanding of segmentation and importance of binary images, let's look at performing our own simple thresholding. First, we will load the black and white image. So here, to do that, we need to do that, load the image here, and mread we will use here, and we have the blob underscore detect dot png image with us, and with the value of 0 explicitly, and this will tell OpenCV to load it as a black and white image. Now the next, take the height and width of this image, and so height and width b dot shape, and here we need to pause the 0 to 2 to indicate we only want to first 2 values from the shape. So now finally let's go ahead and show the image. cv2.mshow, and here just original wbw, black and white, the image. So now the goal is to implement straightforward the thresholding method to extract the objects from the image. We can do that by assigning all objects to the value from 1 and everything else to 0. To begin with, we initialize binary and variable type binary. Just let's see here, the binary is equal to np dot zeros, and here we need to pass the height and width with the 1. Next we will pass the unsigned integer at that's the type. Unsigned integer type. And now we can also start by setting threshold. This is somewhat of the guess, but this is the initial value of the everything. So here we are setting the threshold as thresh is equal to 85. Here value you can set as per your own, but knowing that our unsigned integer 8-bit image will have maximum value of 255 and minimum value to 0. So next we can start our just a simple loop to do the threshold for row in range 0 to height, and for that let's code here for now for row in range 0 to height, and pause here for column in range, and here 0 to width, and then if condition black and white image, the row and col is greater than threshold, then binary row and col is equal to 255. Now I realize it just said that the binary image is consisting of the either zeros or 1, but in this case we can want to display the image user interface and because of the OpenCV GUI requirements, we want to actually show a 255 or 0 value based image. That way the binary image will appear white where they actually want our objects. Pressing enter, then create our mshow using the CV2. GSCV2.mshow, and here slow binary, and here binary needs to pass on it. So now we need to, as we have already means like slow binary show, because this much slower method than another ways that you can do an OpenCV, but nonetheless it shows how you can iterate through the pixels. At this point we can type just cv2 dot wait key and pass the 0, and cv2 dot destroy all windows. So here just needs to check in the terminal we have already here in this folder, and just Python 3 and 02.py file is here. Is not defined where we have used here CV2. We need to do that. So here if you see there are the two images, that is the below detect original black and white image, and this one is the slow binary. We can then see the left side being the original black-white image we loaded, and the right side being the result of our binary segmentation. We can notice easily that the couple of the items such as the long oval here did not appear in our threshold due to all of its value being less than our 85. Additionally, you notice that some of objects are cut off and truncated, such as this long bar here, due to values of this gradient depending on what we were trying to accomplish by extracting objects out of this image. We may adjust our threshold to either compensate for more areas to include or even segment out more of the objects. So now move to the our script here again, and then we need to write some other code like here the other method for getting the binary segmentation out of black and white image. So here is a built-in method that is a lot faster than double nested loop above. To use this we can type the just only over here ret and thresh is equal to cv2 dot threshold, that is the built-in method, and here black and white thresh 255 and cv2 dot thresh underscore binary, and then cv2 dot mshow, and here the cv2 threshold, and here pass the thresh. Now just for further details you can read the documentation of the thresh binary function as well. And now just we need to run this code again here, and if you see here just call its function, and you can say a result as CV is. Just again, sorry here. So if you see here, we have this CV2 threshold, and here the slow binary, and this is the original black and white. If you see here, this is the similar result we see, but this is the built-in function we have used, and it's a crucial function and have a lot of applications, so you can learn through about it as well. So thank you. I'll be back with next lecture.